open these. Heater cartridge, 12 volt, it's extension, and nitride thermal paste. Here's the new power adapter. So this is printed on the Artemis. Oops. there's the hot end. You can see how tiny that thing is. Okay, so tiny little thermistor. Okay, so looks like the thermistor has just long enough of a cable to reach that, so I don't need an extension. So it has a Molex connector end, and then the fan is really small, a little 12-volt fan. As far as I know, it's 12 volt. It's 12 volts, so I'm probably going to stick with a 12 volt system for the batteries. And there is a this is the hot end fan connector right here. So, and then this is the heater board part. And there's another jumper for the print fan here, but I don't need it because I'm going to be running out of bird air. It looks like it's a 6-pin connector for the whip, or for the wire coming out of it. Hot end plus and minus, hot end fan plus and minus, part cooling fan plus or minus, and then the secondary output is our Modbus ground, or mod. Is that the communication? No, it's not. And then there's three. Why is there so many thermistor inputs? There's additional thermistor inputs. Oh, okay. So reset, clock, ground. I think that's for programming. So it looks like basically your ground out mod VCC out. So that might be the probing. I gotta look at those instructions. But so the duet effector and the mosquito hot end. I'm waiting on the mount for it, which it's already shipped, so that should come in soon. But there's a lot of accessories I got, like extension cable, meter long extension cable, which doesn't look like I'm gonna need it, but I got one in just in case. And I actually happen to have 2 heater cartridges. So I have a 12 volt and a 24 volt. I ordered the 12 volt because you can't really see 12 volt. Yep. Okay. Basically, it comes with a really long cable, which is great. Well, I'm going to cut it at the insulation point and mount it to the duet effector. I could also bypass that, but I don't know if there's a good, the duet effector doesn't really have a hole for wire channel, so I'm just going to use the pass-through here, but I think that also might provide 12 volts to the fan. So, well, no, it's a separate fan output, so I might be running some redundant wiring for the hot end fan. And then I also got some boron nitride thermal paste with a little applicator inside of it. Kind of hard to see. Hey, Ronnie, right? Professor Porpoise. Cool. So it also came with all the wrenches that I needed for it. While you're here, let me show you the hot end again. I don't have everything completely hooked up, but my parts are looking kind of messy, so I might clean up a little bit, but essentially it says made in USA. There's a picture of the mosquito on the side of it. There's holes throughout the block that have a little set screw on either side, so it looks like the set screws on either side just hold it in, and I'm assuming the boron nitride kind of sticks the thermistor inside there, because the thermistor is not in there, it's like loose. So I think you just put thermal paste in there, and then the heater block is in there. I'm gonna look that up. We didn't quite get all the instructions. So let's go to their website. Slice Engineering. So they have CAD files. They actually have a CAD file which I was going to use to build a Delta. A analog to digital conversion table for the thermistor, so I can drop that into the Duet control system there. Reference dimensions, safety data sheet. But is there it's compound heat conduction. We suggest using a surface that needs between the heater cartridge and the hot end temperature sensor and hot end. The nozzle and the hot end. Boron is not great for mosquito. Groove mounts. By design, it's created more precision than typical hot end. Produces better presence, but also means some filaments may require more finesse to dial in settings, especially check them. So hot end jamming. Yeah, so 50 watts. Overbuild stuff on this. This is one of them. It's a heavy-duty power connector. I'm also going to add a fuse, probably somewhere around 6 to 8 amps, so it doesn't draw too much. But really, 50 watts is only about 4 or 5, less than like 4-ish amps, like 12 volts. Oh, sorry. No, the battery's probably dead. Give me 1 second. I'm gonna switch. Okay, let me know if you can hear me now. This is my headset. Okay, cool, thank you. Cold pull, if that doesn't work, has been designed. High temperature materials are fine. Simply disassemble the mosquito by removing the hot block and heat break filament path from the heatsink. Black component with the mosquito logo on it. Try removing tiny screws. Place the hot block and heat break into an oven at 500 C. Is that right? 500 degrees C. And burn out the plastic. I think they mean F. No, I have not. Mainly because for time, I don't want to. I kind of want to get the stock H2 running. because I still got to work on the backpack components, and that's more important to get this thing running. But since I have the Mosquito hot end, I'm getting the Duet effector mount, and I have a Duet, and I printed the Duet adapter board. I think I'm just gonna switch all my components right now, and then work on it kind of custom without having. The problem is I have to do some calibration to get it working with all the new components, because they're not the same as the stock H2. So the less issues I have, the better. So I might end up having to switch it back to stock hot end and the Rambo board, but I think the Duet stuff should work pretty well. The other thing I did too is I charged and balanced all my Lipo batteries. So I have 4 Lipo batteries, and these are going to be the power source for this machine. So right now I have 2 in parallel. My idea is to have 3 in parallel, and then switch out 1 battery every cycle. So if I'm going around a convention, have take one out, charge it, take a fresh one that's already been charged, put it in the lot, then the other 2 would be cycled. And so the idea is that I'm going to give, I want to be able to monitor the voltage of each cell on the battery pack, and if one's draining faster than the others, I'll know which ones I need to eliminate in the future. So I'm either going to do 3 batteries at a time, just because of the increased power draw from the cartridge. I might need, well, it's 1 battery can handle the current draw, so that's not an issue. It's the I still think it's going to draw about 60 watts continuous, which is about 6 amps, 6 or 7 amps. So a 5,000 milliamp hour battery, you know, times 3, that's about 3 hours, 3 or 4 hours. I'm also stepping down the voltage to 12 volts from 14 whatever volts. So by the way, the hot end and the thermistor can do 450 degrees centigrade. The cartridge is 50 watts, so it is twice as powerful as most. Well, I think it's more powerful than the E3D one that I know of, but it also can withstand the high temperature. So, but the Mosquito hot end itself is designed to go 450 degrees centigrade. So yeah, it's gonna be interesting. Main thing is getting it working like in time for Murph. I don't know, like, this is quickly becoming a very crazy project. So organize my table a little bit. So all the hot end parts here. Okay, so batteries are, I got a Lipo battery pack, so I'm gonna put this away for now. The thing with the Lipo batteries, again, is I want to make sure they're fused. If anything shorts, I want it to immediately, like if anything shorts the battery pack, that's like the first thing I want to do, is have a fuse to blow. So like I want to be able to run this at a as low as the current draw as I can, because I don't want this to cause like a fire. And it also is not going to be just a backpack. It's going to be, it's going to do other things. Like I want it to actually be portable. So again, like with this, I have, I bought these, they're called Speak On connectors, and they're twist to connect. high current draw. And Practical Printing, Chris from Practical Printing, came up with this as a heat bed solution. So I can add a Orion heat bed and then use this as a high current draw with a Xbox 360 power supply, which I have one. It's a 200 watt or 190 watt, which is plenty of power. So 190 watt power supply. That it's like a power brick about as big as my laptop power brick. But I mean, you throw that in a bag, a roll of filament, and a spool holder, and like, and your backpack with your laptop, and then you carry your printer. I could carry this with me. I'm looking into a handle option too on the top. So there's definitely going to be a handle. I just have to design it. But I want a handle. The Aris had a handle, and so I want this to have a handle as well. If I'm not going to backpack it, I want to be able to also remove the backpack frame easily. So I'm going to have standoffs that go top and bottom, and those are actually going to latch on to the top and bottom extrusions. I'm not sure how that's going to work yet, though. Okay, so this is where we're going to start. So I already did the belts. They're already tensioned. I checked all of them. They all move. Let's see, this moves. This moves. This moves. Okay, so hey, Askew View. Yeah. Excuse me. So I was just saying, I was just showing off the mosquito hot end. If you haven't seen it, it's really cool. It's really small, and then I'm adding a duet effector, and so I have the M12 nut coming from 7313 Maker, and the aluminum row stock effector mount. So this whole thing will just be like solid metal, but really lightweight because I'm not going to add. It's basically just as lightweight as I can make it for a. I think there's an upper limit of like what you can do with a Delta. So for this case, the lighter it is, the less inertia I'm gonna have when I move it around on my back. So if I'm jogging or walking, I don't want the hot end to have a bunch of mass and skip the motor. So the other thing I've ran into an issue with is that I didn't think about cooling the duet. So I printed a duet mount, and I want to I want an enclosure that will fit. So I need something low profile. So I have a D-bot in a kit, and I was gonna do this, but you can see how big this is, and it's meant for extrusion. So I need one that's just basic. I also, though, that's the thing, I need one with a fan built into it. So this looks like, oh, I like that idea. It's having the cabling come out of the little hooks on the side. So what side? So it takes an 80mm fan. You jogged the benchy? What does that mean? Oh, cool, it's OpenSCAD, so I can edit it. Yeah, I might bookmark that. Wait, so you mean jog, like... if you want to know on this... Oops, let's see. I'm printing a it's a commission for a Dreamcast mod that somebody wants me to print, so that's what I'm doing there. So that has a fan option. So it's 80mm fan. See, those cases look really big. I don't really want to do it exposed either, because this actually will like weather the elements a little bit. Like at Murph, it was drizzling last time, but I mean, nothing really happened. Oh. So it's not jogging, more of like the backpack. If it's rigidly mounted to my body and I'm bouncing because I'm walking, right? The hot end is, and the effector is floating, and the effector has all the weight on it. Well, okay, all the mass is on the bottom because it's the stepper motors. But essentially the only moving part on the Delta printer is the arms, the carriages, and the effector. So the carriages are not going to matter because all the motion this way is maybe going to affect them, but they're also constrained, because the belt is holding them, the stepper motor is holding them in position. So I'd have to like jump, and that would give a little bit of inertia, but the carriages are really lightweight. The effector is going to have all that momentum pulling down on the end of the effector of the arms, and so there's some leverage going on there. But the good thing is that all three motors are holding their position. So you basically, like static movement, you'd have it holding at 48 ounce inch per stepper, so whatever that translates to. I'm sure there's a lot of physics I could figure out. But the main thing is that like the Aris was not rigid at all. It was pretty amazing for what it was, but it used little 6mm rods, and it had little plastic bushings, and like the belts were like really thin, like GT2 belts, and the towers were just made out of plastic. Like the only thing holding the top was these like the rods and these 3 plastic towers, like tower supports. So this has like a lot more rigidity than the Aris. So again, like everybody was asking me when I did this last year, why it doesn't mess up, and I was telling them because like Delta printers, you have 3 points of constraint. So, and stepper motors are constantly, holding their position, and so as long as the arms don't flex, which I talked about carbon fiber arms, as long as the arms don't flex and the effector doesn't flex, like everything's moving in relative to my motion. So, and the bed doesn't move, so the bed's not gonna hopefully not be shifting. The bed's actually gonna be right at the center of gravity. It's gonna be like right around my mid back, because all the weight is gonna be directly below the bed at the motors here. So really all my pivoting, my hip is actually gonna be here. My hip's gonna be about here. So like all the weight in the center of gravity is going to be where my waist is, and that's going to be a padded weight support. So like anyway, it's pretty solid. Like I never really had problems with. The only issue I had was moving in and out of a building that was cold and hot. Wind actually affected the temperature of the hot end, and I could visibly see layer shifts from temperature changes while I was moving around. So there's a lot of stuff I've considered. So there's a lot of duet boards out there. Oh, that one looks nice. Again, the problem is going to be how thin can I make this? And I want a nice thin box. Like this one actually has an air channel with a 40mm fan. Yeah, so it uses a Noctua 40mm fan. I might have to buy another Noctua fan. Those are really nice. Yeah, let's bookmark that one. Sorry, guys. And if you're not already doing it, you should follow me on Thingiverse. You can see I have. This is the last thing I made. This is the bird air pump upgrade for the Aris. I don't have a lot of people liking it or collecting it, but I thought it was cool. I spent a lot of time learning how to design like that fan mount right there. I made a fan shroud, and I made this cool mount that holds the bird air on the effector, and then this is the actual clip that clips to this tower. Let's see. Yeah, so right there, the bird air just clips to the side. Okay, yeah, nice talking to you. Yeah, I was gonna at least start one. I got distracted here. Okay, so base plate. So install the top assembly. So I might have to get off the stool and find the base plate. So locate the top assembly base plate, shown as image. 3 1/4 inch by 20 button head screws and 3 T-slot nuts. Okay, so let's move these towers out of the way. All the electronics. Yeah, Duet has been awesome, by the way. These are my voltage checkers. So I'm gonna have battery voltage checkers on each one, battery alarms, because I over discharged the batteries. Okay, so there's 4 of these sheets in total. It looks like the one that they're looking at is the top, which is this one. Okay. Okay, so they have X, Y, and Z facing up, so I'm going to flip it this way. And here are my 1/4 20 bolts. I should add a 1/4 20 so I can add a GoPro mount to it, but we'll get to that later. I am going to add a GoPro probably to the top of this so I can see what's going on. Actually, I want to add one kind of next to the print so I can see the print and then see everybody's reaction behind me. But then also the GoPro has a wireless feature, so I'm gonna add I'm gonna see if I can get 5 volts, a 5 volt out from my batteries, which I have a 5 volt regulator, so I could get a separate USB out, and that should charge the camera. But if anybody knows a smaller Wi-Fi camera that works in ad hoc mode, the Pi Cam didn't really work too well, so the GoPro has a better lens. You'll need to install the C tower first. Do so, flip upside down and slide a T slot. Flip is upside down. Oh, flip it upside down and slide T slot nut into the T slot as shown. Align the nut as shown. Next, install the top assembly plate. Ensure you get the Z tower position with the Z tower, aligning the tabs and cutouts. Hold the panel flush against the tower plates. Look through the hole for the 1/4 20-volt, and T-slot is centered with the hole. If it's not, use your hex driver to move in this position. If you have trouble getting the button screws to engage the T-slot, first ensure that you have a nut assigned. Okay, ensure that the T-slot nut is centered. If you have trouble, first ensure that you have the nut aligned with the hole. Second, loosen the head slightly on the side plates. Insert and tighten. You can fully tighten the screw. Okay, so this is not, the top side has the screws right here. So these 3. But it's going to fall out when you go upside down. No, actually, leave that. And then you take the tower, which this is. This is XY. Okay, so this is the, get this light out of the way. So the Z is upside down, and then we'll take a T-nut, flange facing away. It says, or the ridge on the nut should be facing away from the head of the button screw. Okay. So we take Z, fit it, push it into the slot. Oh, okay, got it. And then tighten. There we go. So it engaged. Now I need my 5mm. I should have just got T slot. So. 4mm. No. 4. Ah, there we go. Okay. Awesome. Okay, so that's not too bad. So this does feel kind of bad, but like it's actually not bad at all. Like it's pretty strong look feeling. The thing is that you have a top and bottom section that's gonna mount on both sides of the extrusion, and you have these short extrusions, so it actually does feel pretty stiff. But again, all the tension is on these plywood pieces. So again, if I can make this out of, I think the next step for me is going to making this out of aluminum. All the panels out of aluminum, because it's totally doable. They're all 2D cut. All I have to do is water jet them and then add a little bit more, add some radiuses, like tolerances for the radiuses, so the parts that need to slot into each other actually fit tightly. And since they're aluminum, you know, you can get tighter tolerances than plywood. Let's see here. You install the Z tower. Okay. Next, install the top assembly plate. Okay. Perform the procedure. Previous steps remaining. 2 towers. When complete, assembly should look like these images. Okay, so this is going to be challenging because I'm going to have to hold these upright, upside down. Okay, let's do this. Nope, it's not going to balance. What if I do this? What if I just hang it? Yeah, that's kind of scary. Okay. Take a 1/4 20-volt. Nope, I already have one. Take a T-nut. Put the flange away. Okay, now take this part. Put this in the Y. So we're doing ZYX. There we go. I'm trying to get that Z-nut engaged. Oh, let's move the light out of the way. Okay. There you go. I got it to catch. So if I check inside there, okay, so I should see this actually bite. Oh yeah, okay, so I see the threading now. Cool. This melamine is pretty tough stuff. Okay. And then this one, just to make sure. It's pretty tight too. Okay. Now we have the third tower. Let's raise this up, that. And Okay. So far, so good. Okay, so this gives me a good indication of where I can mount things. Aha. On the top, my idea was here. Using these holes here. There's a bunch of holes cut out here. Basically just creating a bracket that mounts from here, going maybe 100 millimeters out to the backpack, and sandwiching this top plate, and the same on the bottom. That way I can remove it with just wing nuts and 4 bolts. But these are kind of small holes, and the other thing too is all the weight would be pressing on these melamine sheets. So I might have to add some reinforcement, but like the Aris had the same thing. The thing on the Aris is these little base plates up here at the top where the feet are, is I can remove those feet and just create standoffs and directly screw those I can get to they're only nylon, so if I could just basically screw those into a base plate that has slots for the bottom brace here. Either way, I could basically mount the feet, rigidly mount the feet to the base plate, and then the top would just hold on to a spacer here that jets out to the top of the frame, and then all this is open space. The main thing is the top and bottom have to be rigidly mounted, and they have to be spaced out my back and the printer have to have at least 6 inches of space or 4 inches of space, because I'm actually going to be mounting a spool right around like here, kind of where the towers are out of the way, or where the effector is going to be out of the way. The other option is not doing that and adding the spool holder at the bottom of the base plate like the original one. But the thing with that is I'm going to have to make sure that the filament doesn't get tangled. So I might have a solution for that. I'm actually thinking about just printing a box, a filament box that's like fully enclose a spool, and have a built-in Lazy Susan, and then have a button coupler coming out of it that goes to that feeds directly to the Bondtech extruder. Issue with that is it's going to be really hard for me to get the filament out of that. So the spool holder is going to probably not change too much, but from the original design. What else? Okay, so okay, so this is where things are going to change. Here, let me move the printer out of the way. And let me grab this. This is the base plate assembly. So 6 by 12, so 6 millimeter by, or it's not millimeter, it's by half. Again, what is a half inch? Okay, so these are 6 by half to 4 standoffs. So I'm going to change this up because this plate here is going to line up with those standoff holes. Like this. Like this. 2, 3, 4. Nope. Like this. Nope, that's not gonna work. And I have to have standoffs because I think this is gonna get in the way. So this printed adapter doesn't even look like it's gonna work. Oh, it's upside down, but that shouldn't make a difference. I'm gonna have to ask Eric how he did it, because I don't think these holes are gonna line up. No, it sticks out too far. If I do this. I'm not sure the rhyme or reason for these hole patterns. If anybody knows that has an H2, I'd be curious to know. I think Chris has one too. Chris has one of these adapter plates. Chris, practical printing. No, there's no alignment holes. And this is meant for an ANET A8. So I think they use a different original board. So I might be stuck on that. I could put these standoffs, and maybe he did it where he uses a plate that mounts the duet to it, but then it has a smaller, but he uses a Maestro, so this, they're not the same. The whole pattern looks different. That's the right board. Just doesn't look like the picture. Okay, for this board, that would make sense. Okay. Sorry, I was a little confused. But for the Rambo board, that will work. And then what I'm probably going to do is just find a Rambo to Rambo the duet adapter, or get a filament box, or a duet box. But the duet box, I want to just directly mount to here, but you have to get to the wire guide under here. So the duet would have to be risen, and I have to add a fan, but the fan has to be really thin. So I'm actually looking maybe a laptop blower fan as an alternative. That would be kind of interesting. Problem is I can't find more of these screws. Here we go. If there's anybody watching, I'd like to see what your comments are on how I can mount the duet board. Most likely, it's going to have to be an adapter from a Rambo to a duet adapter, so I can use the same hole placement. I could also just drill a hole. I can drill holes for the standoffs. I can get the duet board, and I'll show you size comparison. So this is the duet. That's the footprint of the duet. And here's the Rambo. The Rambo's like about an inch smaller square rectangle. So if I was to mount this right here, we have to be careful with static. But oh, nice. They have a 10, a 15, and a 7.5 amp fuse. Okay, this is interesting. So if I go move these over one, it's almost like this was laser cut to kind of be able to accommodate both Duet and Rambo, which would be interesting if they came out with a Duet version of the H2, like a native one. Especially if they could sell it for the same $500 price tag. So let's say I did this. Oh my god, that is perfect. Wow. That is almost perfect. It's not even quite perfect though. See what I'm saying? That the spacing here is good, but I would have to drill holes out here, and it might get a little tight with the rest of the controller board. So this is the bottom of the machine, kind of. So I kind of still have unprotected parts here, and I'd have to have a fan blowing across the driver chips here. So I might have to have a little 30mm fan here that just blows down this channel, or I know, just for now I'm going to put the screws in these outside holes, and I didn't get far today, so I'm going to do it tomorrow. But I might have to make some custom adapters. No big deal. Or I might just drill into this part, or I could laser cut this part. But I think I'd rather drill it. I can make a template so I can get precise holes. Let's say I do this. So there's a tiny little LED for the Z-stop that it like almost fits, but not quite. And there's a lip here. That's the problem. And the stepper motor for the extruder is going to be like right there. So it's almost too close. I can fudge these. Oh, let's do that. Oh. And we might still need a printed adapter, but let's see how close I can get. Yeah, it's not rigidly mounted because it's not grabbing the corners. And I don't want to mess up the LED on this corner, so so close, so close. But it looks like mounting the base plate. Like, we won't even get to the electronics until after the wiring is done. So that's when we're gonna be installing the board next. So it looks like I'm gonna have to do all the duet versions of the wiring after I build the right adapter. So this adapter didn't work, which means I'm gonna have to do some research. It looks like the duet part is correct here. I could build a cage around it, like a skeleton cage around this board. What's interesting is where the mounting holes are supposed to be placed. It just doesn't make sense. Like, unless I get some different version. Yeah, I don't think this is gonna work, so I didn't think it would. So I'm gonna take this board off because we can get back to this later. It's holding, but it can still slide, so that's not good. But the other thing I could do is just use OpenSCAD and make an adapter plate. And then the fan, I can just basically clip onto the okay, with the skeleton, this is a 30mm fan. I'd have to add a 40mm fan that goes outside of it, right there, that blows directly on the drives, on the drive side. And he says it centers it, which means anyway, you want to center the board pretty much like you would center the Rambo board, because the Rambo board would sit in here like this, probably with the fuse side there and the USB side on the outside, because obviously you can plug directly through USB. Same with the Duet, you got the chip side and the Wi-Fi side, which you want the Wi-Fi antenna to be sticking out. So, so it says to mount. Okay, I might not be able to show this part, but I'm going to do it from, I'm going to install the base plate on here, and then I'll have to move the camera next to my stream. So, base plate here. Here, let's see if this will work. Okay, so that doesn't matter. As long as Z is on Z. Okay. Good. Nothing in the way. Okay. Gotta slide those T-nuts out. These are tight. That's why they tell you not to tighten these screws, because they get in the way. Cool. So you should screw right in. Awesome. Y, X, and Z. Okay. And then, so this is going to change because I am gonna repin these connectors for the duet. So right now everything from this point on is gonna change for the duet. So I think I'm at a stopping point. Because I need to mount the duet and I need to recrimp all the wires for the duet connectors, and then I'll have a better idea of what I'm doing. Plus by then the 713 maker parts should be in, and again, like the smart effector has its own oops, wrong camera. Smart effector has its own parts. It has Molex, 6-pin Molex mini fit. Even comes with this beautiful E3D heatsink. So if I want to swap, I can easily switch between an E3D Volcano or just an E3D basic hot end and the Mosquito, almost with nothing more than just a connector. So it'd take me like a few minutes to swap hot ends, which is really cool. What else? Yeah, so right now we're stuck on the duet mounting problem. So put you guys back up here. Oh, that's not where I want to put you guys. Right at eye level with me. Oh, it's a good picture. Oh, flip that. Okay. Top down view. Kind of crooked, but there you go. So, we're not that far off. Right now it's just going to be electronics and figuring out mod stuff. So, but I'm going to end the stream there. So.